Alright, so we've done the indefinite integral, which the indefinite integral is a family of functions. Alright, it is, when you do the indefinite integral, you always got that plus c kind of at the back end. It represents all the possible functions that would have the derivative of what you were integrating or what you were doing the antiderivative of. So, indefinite because it's not necessarily a definite answer. Okay, it's kind of the way I like to think of it. It's not a definite solution because it could be a lot of different things depending on what c is. Now, a definite integral, okay, is actually going to be a value, all right, or a limit in a sense. Sorry. The definite integral will be the limit as delta x approaches 0, and this will look really familiar, of the sum as I goes from 1 to n of f of x of I delta x. Again, where delta x equals b minus a over n. Very similar way of writing the Riemann sums that we've done in the past. The difference was as n goes from 1 to infinity, all right? But this would be, as delta x goes to 0, well, delta x would be approaching 0 if n was going towards infinity. So it's kind of saying the same thing. Yeah?
What's that on the bottom? What equals 1 there?
Is that
I. Yep, sorry. I. As I equals 1 to n. Okay? This is the notation straight out of the textbook. It's basically saying if you were to sum all of those rectangles together as the change in x got smaller and smaller and smaller and smaller, okay, you would be finding the definite integral.
What is the limit approaching of the change of x?
The limit as delta x approaches 0.
Oh, that's a 0.
Yep. The limit as delta x approaches 0 of the sum as I goes from 1 to n of f of x of I delta x, where delta x is b minus a over n. So it's very similar to what we were using for Riemann sums. It's written a little bit differently, but it's saying, in a sense, the same thing. So the limit of all those rectangles added together as the delta x got really, really small, or in other words, as n got really, really large, like we did it with the Riemann sums, whatever that equals, that value, that number, okay, that is your definite integral. So the definite integral is a value, okay? It's the limit of all those rectangles added together, in a sense, if you want to think of it that way. All right? So I'll write this out in words. The limit is called the definite integral. Of f from a to b. The limit, so in other words, the value that you get by doing the limit, that is called the definite integral of f from a to b. Keep in mind, I'm going to stress again, indefinite integral is a family of functions. The indefinite integral has that plus c on the end. So it could be 2x plus c, which represents an infinite number of functions. That's an indefinite integral. You're not getting an exact value or anything. The definite integral, when you do the definite integral, you are getting a value. You're getting a number. Okay, you are getting.
This stuff we did yesterday, that's still indefinite. Or you like that?
That was.
Because it gave us like the point.
That was you were finding the indefinite integral, but then you were able to solve that differential equation given an initial set of
But it's
conditions.
still indefinite.
Yeah, you're not, it's not a value, it's gonna be a function. Yesterday was a function, this will be a number, this will be what you get by doing the limit of those sums. Okay? Now, to add on to that just a little bit here. If f is continuous, on a closed interval AB, and non-negative, okay? Yep. I mean, it could be 0 too, in a sense. And the area
Wait, what's BA?
Huh?
Have we seen that with B and A?
You just did on the previous slide.
Yeah, that's right. Never mind.
That is the definite
I was
integral.
having a moment.
It's alright. So assuming the entire function is above 0 and it's continuous, this is what you will use to help you find eventually the shortcut to the area under the curve. Alright?
So if it's not,
Have to,
right.
you can still use it, but I can't teach you how it works. But that's kind of later on.
So is that what you were doing?
So, I was actually using the fundamental theorem of calculus, which uses this idea, it kind of puts it all together. We're about a couple weeks away, or within a week probably. Okay. So assuming the function is continuous from A to B and non-negative from A to B, so everything's above the x-axis, the area under that curve can be found using the rule, the limit rule for the definite integral. Okay. Now again, we're not quite putting everything together, we're kind of going slowly here. This is just a definition of the definite integral. And I'll do some problems like you're going to have here in a second. We got that picture? Alright. So, here's what I'm asking you to do when you see a problem like this. It says draw the definite integral from 1 to 3 of 4 dx. 4 is your function. Y equals 4. Y equals 4 is a horizontal line at 4. Okay? So really I'm asking you to draw the line y equals 4. Draw the function y equals 4. And find the area under the curve from 1 to 3.
So that would just be 2 times 4, right?
Yes. But the drawing has to happen as well. So I know that you know what we're talking about here. when you see this, I want you to understand that it's basically asking, or it is asking you to find the area under the curve from 1 to 3. This is a nice shape, it's just a rectangle, pretty easy to find the area. Okay. Base times height, what do we get for area? 8, right? Okay. So area equals base times height, so this base 2 times 4, which would be 8 units squared. Okay?
Can we just make up a unit?
Sure.
Okay.
He just really doesn't like
I know.
units.
I'll keep using them.
In this way, all of us will be happy.
Everybody got that one?
This one.
Okay. Try that one. Draw the picture, find the area.
Do we have to draw the picture? Sorry. Sorry.
I hope you can hear that video.
I didn't mean to actually say that out loud.
You summed up my life.
Draw the picture, find the area. Yep. The biggest thing I'm trying to get across in these type of problems is for you to understand that when you see this, you're finding the area under that curve from 0 to 3, getting you to understand that that's what it is. That's what it can be when everything's above 0, which I'm giving you ones where everything will be above 0. Right. So when you see this, this is what it's asking you, this is what you are finding. You are finding the area under the curve x plus 2. I know it's not a curve, it's a line, okay, but they will be eventually curves, all right? Finding the area under x plus 2 down to the x-axis from 0 to 3. However you want to do this, if you want to think of this as a rectangle and a triangle, you go for it. To me, it'd just be a trapezoid, be just as simple. But however you would like to do it is fine. I'm going to go trapezoid. Looking at it sideways, my height is 3. The length of this base is 2. The length of that base is 5. So 7 times 3 is 21 times half. 10.5 units squared.
Meters a square.
Okay?
Yes, they do.
Bryce, what do they call me?
The steel
Either
trap.
big positive or Johnny Cash.
What did I say?
I don't know anyone who calls you that.
Hey, Johnny
Do
Cash.
people- yeah.
There you go. Now
Especially
you know
if you have to whisper it to him first.
it's- But people call me big positive. You know why?
Literally his contact name in my phone.
Big positive. And Johnny Cash.
In book. My phone said.
I have a charger.
I have an app.
Okay, so far? Give you another one.
After class. Unless you want to black out. Black out.
I'd love to black out.
Wow.
bring back some advanced math memories.
I was trying to forget that.
All I remember is TJ was not very good.
Hit it. I want you to hit him.
So upside down,
Fight has to be a fight.
right two? No. Oh, how to draw this.
Excuse you.
Remember what that was?
Yeah, I do.
What?
That's,
That's the
Standard
same
form.
as that.
Of a
of a
circle.
circle.
Centered at the origin with a radius of
Four.
2.
Oh, yeah.
Golly.
This is
Oh,
a
that's
circle
what this is.
centered at the origin, radius of 2.
That's interesting.
So y squared equals 4 minus x squared, right?
Then square root.
Got the same thing.
Are you
If
trying
you're
to-
just talking about the positive one, basically you're looking at the top half of a circle
With a center.
with a center at the origin and a radius of 2.
This makes this easier.
Absolutely.
Oh, so it's just half.
So
It's a semicircle.
we do pi r squared.
Very
Over
good.
2.
Johnny Cash.
Maybe one.
Big positive.
Alright.
They also call me Johnny Paycheck.
So just 2 pi,
Right?
right?
On page
Because it's
10.
over 2. Because it's pi r squared. R squared.
4 minus x squared would be a circle centered at the origin with a radius of 2 because it's just a positive. You're only looking at the top half of the circle, so we're finding the area of half of a circle is what this ends up being. The area of a circle, remember, is pi r squared, so you'll do pi r squared divided by 2.
So 2 pi?
Radius is 2. 2 squared is 4. 4 pi divided by 2 would be 2 pi units squared.
Meter squared. Do we have to write radius 2 or just know
I'm
it?
writing it there so people know how I got my answer.
Well, I just want to make sure that I'm not missing part of my.
Nope, that's fine.
Writing on
You
the
do not
test.
need to write that there.
Okay.
But in
And we
case
will be-
people watching the video have no idea how I went from this to this, other than me saying it, I figured I'd write it down.
And we'll be expected to know formulas like that back from, alright.
Or you just graph it.
Got a calculator.
That works.
Yep. Okay.
Graph it. Graph that.
Alright. So the ones today are just like the ones I showed you right there. I guess the only other thing that you could see is
I'll take your word for it.
no idea what this is. Let's just say it's
12. Yes. Just 12.
minus 3 so x squared minus 6.
At which point we give up and run away.
And
Hey.
no idea if that's right.
Well, yeah.
Sure.
That's all that matters.
I'm completely making this function up.
You went outside.
But I gave you the picture and asked you to write the definite integral that represents that.
Oh.
Just going the exact opposite.
Yeah.
S.
Integral,
Yes.
not s.
8
3 to 8
of that. D of x.
x squared minus 6x plus 12 dx.
Can you do me a favor?
Yeah.
Can you write an S on the board? Alright, why do you start at the top there and at the bottom?
That's what I said. You said that before.
It
There's
looks
no
a lot
difference.
prettier when you do it like that.
So the
I
integrals.
really took my time though.
Integrals long and skinny.
See?
Yeah.
Yes.
Yeah.
Wow. Looks the
Now
same
try
on
it the
one.
other way.
Now go from the bottom.
Why do you do that?
Yeah,
That's
that's
just-
awkward.
Did your teacher
Works.
do that in the high school?
The man do what he wants.
I don't know. I don't know how to.
Do 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 do.
That's how my
That's weird.
brain is processing that I need to take the sum
Backwards,
from
everything
down,
Oh.
sum the lower number to the higher number.
Now
I'm
you're
finding
just
the
trying.
Yeah.
Oh no, this is how it works. You guys are full of it.
Or are you the one who is full of it?
Shut up, Bryce.